Alright, today's lesson, guys, is on the Pythagorean theorem, which we've seen plenty of already, but let's just get right into it. A squared plus b squared equals c squared. Remember, c squared by itself, it's always the one across from the bar. So, let's get right into it. If I have a is 6, b is 8, well, literally, all I'm doing, a squared plus b squared equals c squared, plug in what I know. 6 squared plus 8 squared equals c squared. That means when I add those up, I'll get 100 equals c squared. Take the square root of both sides, give me c equals 10. For this one here, a squared, I don't know it, so a squared plus 5 squared equals 13 squared. I'm going to subtract this 5 squared from both sides, subtract 25 from, this is 169. So that gives me 144 when I do that subtraction. Take the square root and get a is equal to 12. And this last one here, 6 squared plus b squared equals 11 squared. So that means, again, 36 plus b squared equals 121. I'm going to do that subtraction and get b squared is equal to 121 minus 36, which is 85. And then again, take the square root. The square root of 85 doesn't really exist. Well, it exists, but it's not an equal number. So I'm going to say just leave it as root 85. If you type it into your calculator, you would get out a decimal. It would be like 9.2. This is the more preferred answer, the one that has the square root as it. If they want an approximation, though, 9.2 is just 5. So one of the ways you'll do something with this is with finding areas of triangles. So here's an isosceles triangle with sides of 10, 10, and 16. And to find the area, we need to find what this height is. Well, we can do that by, with the isosceles triangle, it means it's getting cut in half, this base down here. So that means each of these is 8, which means now I can find the height using Pythagorean theorem. I can say that a squared, we'll say that's this altitude, plus the base, or plus b squared, 8 squared, will equal 10 squared. So like we did before, a squared plus 64 equals 100. That means a squared equals 36, and a equals 6. That means this line up the middle is 6. So, to find the area equals 1/2 base times height. Well, the base is this big long segment, 16, and the height is what we just found, 6. 1/2 times 16 times 6, which gives me 48. Now, if these are all in inches, that means that my area should be inches squared. Here's 2 more examples. Give these a try. I would pause the video and complete them and come back and see how you did. Alright, how'd you do? First look here. We're going to find this height first, which means each is 12. So that means that a squared plus 12 squared is equal to 25 squared. That means when I do this substitution, a squared plus 144 equals 625. Do that subtraction. 625 minus 144 will give me 481 over here for a squared, which means a will equal the square root of 481. And again, if I take the decimal approximation, that's 21.9. To find what the area is, 1/2 base times height. The base is 24. The height is at 21.9. Do that multiplication, and you should get an answer of 263.2 inches squared. Same thing over here. We need to reach not 12, there's 7 and 7 this time. So we're going to do 7 squared plus b squared equals 25 squared. Again, whether this is called a or b doesn't matter. I'll get b squared here is equal to whatever 25 squared minus 7 squared is, which was 576. Take the square root here, I get b is equal to 24. Now I find the area. Area again is 1/2 base times height. 1/2, the base is 14. The height we just found is 24. So 24 times 14 times 1/2 will give me an answer of 168 inches squared. And there's your look at Pythagorean theorem. From here we're going to go into application problems. So be ready.